All right, thank you. Good afternoon, everyone. I'm Wang from the University of Florida, and I'm here to present our work on exploring virtual agents for augmented reality. So just to start off, when I talk about augmented reality, or AR, I'm referring to being able to see virtual content superimposed onto the real world, like a hologram. AR headsets, such as the Microsoft HoloLens here, enable users to manipulate and interact with this virtual content in a natural and hands-free manner. One common way right now to provide a hands-free interface is through the use of a virtual agent, like the digital assistants we currently have on our smartphones. Now, what we could do is simply port these agents over to AR headsets, and thus enabling natural and hands-free interaction there. But these agents weren't really made for AR, and don't take full advantage of its capabilities. For the most part, these agents don't have any visuals, or rather embodiment, to them. Based on prior work, we know that there are many benefits to embodiments, such as helping with rapport, likability, and being able to enrich interaction through nonverbal communication, such as gestures. Similarly, from human-robot interaction, we know that having a physical presence would have an impact on learning and overall bring more influence to the table based on just an agent or robot being there with the user. In the context of AR, giving an agent some sort of body would make sense, as AR is designed to give things a virtual presence in the real world. But then that raises the question, would embodiment translate well to AR, and is that what users really want? So our goal was to explore how different agent representations in augmented reality would affect how a user perceives the agent and how users behave differently, if at all. For example, what about having a tiny person on your desk? Or maybe a virtual smart device to interact with? Or could that be too distracting? We wanted to understand what users would prefer to work with in an AR environment and how they would react and respond to different visual representations for virtual agents. So to study this, we created a scenario which was inspired by a prior study by Gavin et al. And what we did is we had people wear an AR headset and search for hidden objects and images while interacting with a virtual agent that would accompany them in AR. We wanted a task that would keep users engaged while also having an agent alongside them that could give hints and help complete the task, ultimately acting like an assistant. For these tasks, what we did is we created a hidden object game that ran on a touchscreen PC. And we borrowed images from the I Spy series of children's books to use as the puzzles. How things would work is that a user would need to find one object hidden in each image. For example, the cat shown here. A user would need to interact with the agent in order to learn what they are looking for and ask it for hints if they got stuck. Then, once the user found the object, they would just tap on it to move on. Our agent supported the 4 different hints that would describe the object, which were context, color, shape, and location. So we designed 4 different agents for users to interact with. The first, Ava, was a voice-only agent, and so users did not see anything. Instead, they just heard a voice through the headset. The second agent, Z, was made to mimic a smart home device and stood on the desk in front of them. The third agent, Mikey, was a miniature human that also stood on the desk. And our fourth agent, Jake, was a full-scale human agent that sat at the desk across from them. And the goal was that these would give a sampling of the range of different visuals for an agent, 2 agents that mimicked existing devices, and 2 agents that were embodied. For our study, we recruited 24 participants to interact with the different agents and find the objects. Participants wore the Microsoft HoloLens 1 headset and sat in front of an HP Sprout touchscreen computer, which had the hidden object game running on it. We used a within-subjects design, so each participant got to interact with all 4 agents, and the order of agents was counterbalanced with the Latin square. Each participant would complete 5 different puzzles with each agent, and they would fill out a questionnaire after each set that asked them to rate their experiences with the agent. So, to put it all together, here's an example of a user searching for an object in an image while interacting with our agent, Mikey.
All right, cool. Hi, Mikey. What am I looking for?
Try and find the baseball player. Let me know if you want a hint.
Can I get a hint?
Sure. What kind of hint do you want? context, color, shape, or location.
Location.
The baseball player is in the second keyhole from the right.
What's color?
The player is white and yellow.
Okay. During each trial, we measured how long it took for a participant to find an object in an image, and we also recorded their utterances, so what they said and how often. We also kept track of how often participants gazed at the agent, which, due to the field of view of the headset, we estimated by seeing if the agent's face or the agent was visible on the screen. Again, we asked participants to fill out a questionnaire after each agent, and we asked them to explain what they liked most and least about each agent, and also at the end of this study, to state which one out of the 4 they liked the most and least, and why. We also asked them to rate each agent along 8 different scales, which were adapted from previous studies on agents as well as AR/VR. For some of these metrics, we would expect the results to be the same across agents, such as task completion time or helpfulness, because the agents shared the same intelligence. Instead, they just had different visual representations. For purposes of this talk, I'm only going to highlight the results that we found were significant, starting with gaze. So for gaze interaction, we found an effect of agent on gaze behavior, both in terms of the number of gazes as well as gaze duration. For this, we only looked at the 3 agents that could be seen, which were Z, Jake, and Mikey. Post-hoc tests with pairwise t-tests with Bonferroni correction showed that our participants gazed more at the 2 human-like agents versus the non-human agent Z. And likewise, we found that overall, each gaze was longer in terms of duration as well. Quite often, how this behavior would play out is that a participant would look at an agent, ask a question, and then wait for the agent's response before looking away. Next, I'll talk about the questionnaire ratings. Overall, for these, we found differences for 3 of the scales, which were presence, reliability, and realism. For presence, we asked participants to rate on a visual analog scale how much they agreed with the statement, "I felt like the virtual agent was in the room with me." Statistical analysis and post-hoc tests here showed that the miniature agent Mikey was rated as having a higher level of presence compared to the Z device, which we found was kind of interesting, given that they were both visually apparent and the same size. For relatability, participants rated each agent against the statement, "I could relate to the virtual agent on a personal level." And here, we found that Mikey was rated higher than both Ava and Z in terms of relatability. And for realism, we had the statement, "I felt like I was interacting with a real person." In this case, we found that both our human-like agents, Jake and Mikey, were rated significantly higher than Z. Also note how the average rating for Ava fell somewhat in between, but not significantly different from the others, which I would discuss later on. So going back, at the end of the study, we also asked participants to rate which agent out of the 4 they liked the most and least. Based on their answers, we tallied up the number of people who liked each agent the most, and some people can decide on one, so their votes were split. However, these don't tell the full story here. We also had to take into account the number of people who liked each agent the least, in the form of dislikes. And then we subtracted the dislikes from the likes to get sort of a net score, which allowed us to see the agents that were most preferred. And then you can see here, Mikey was liked the most overall, with Ava in second, but more polarizing, with an almost equal number of likes and dislikes. And then Z, followed by Jake, which were both really close, with more participants disliking them than liking. So, why did our participants like the smaller Mikey agent the most? And what does this mean for the future of agents in AR? Well, in order to answer that, we analyzed the open response questions to get a deeper insight into participants' perceptions of each agent. According to one participant, they liked Mikey because he felt like a little helper that was in the room with me. It wasn't too distracting, and it was amusing because he was so small. From our other results, recall that we also found that Mikey had higher presence and relatability ratings than Ava or Z. Based on these results and participant comments, this is somewhat related to a novelty effect that was reported in prior work, where embodied agents were rated as more engaging and novel compared to others. Additionally, we also found that participants gazed more at the human-like agents Jake and Mikey compared to the smart device Z. And most likely this is because people tend to gaze at faces, or just that there was more visual stimulus for those two agents. But the takeaway is here is that this is good news for having embodiments in AR. One of the key benefits is being able to enrich speech through the use of nonverbal gestures and expressions. What we saw here is that people will gaze at the human-like agents, which is kind of a necessary first step for utilizing nonverbal communication. Moving forward, we also saw that Mikey was liked more than Jake by participants. They had the same design, just one was smaller than the other. So going to the comments, we found that although participants felt Jake was more realistic, he was also considered off-putting and uncanny. One participant wrote, "Having a huge animated guy right next to you was a bit much." So unfortunately, we concluded that Jake fell into the uncanny valley, where he was still fairly realistic or human-like, but not quite enough to be really acceptable. But recall that Jake and Mikey both had the same design, just differed in size. So we saw that size really does have an impact here. A tiny person, of course, does not exist, so it would be considered less human on the scale, but more likable as it avoids the uncanny valley. And there could be other characteristics that one could explore. For example, the design of agents or other factors such as appearance and movement. In the end, though, uncanniness is still an issue that virtual humans face, even in AR. But it looks like size can help mitigate that a bit. And last, I want to talk about something we noticed in the participant comments. Z, the smart device, had a lot of comments about how robotic it felt. For example, since it wasn't a person, but an inanimate object, it felt less like I was interacting with somebody. That makes sense for the two human agents based on the realism ratings that we looked at earlier, where the human-like agents were considered more real than Z. But what about the voice-only agent, Ava, which wasn't rated significantly lower than the other two human-like agents, but instead sat somewhat in between? What made Z come across as more robotic here? Well, reviewing the literature, we came across the notion of an agent having what's called a default image. So in summary, people would consider an agent to be human unless they had evidence to the contrary. So in this case, seeing really is believing. And according to our participants, this is most likely what was happening. Now here's one quote that really epitomized this concept. "I did not see Z's face as it helped me. The first assistant, Ava, had only a voice, which allowed me to imagine that it had a face and thoughts that were just not shown." So my takeaway here is that any non-human appearance could be potentially worse than having no appearance, unless the goal really is to make the agent feel more robotic or thus embody a different role. So in conclusion, do embodiments work for agents in AR, and should we have them? And we would say yes, based on people preferring the smaller embodied agent overall, and how the embodied agents had increased gaze behavior from users, as well as higher ratings for realism, relatability, and presence. Overall, we also showed how the visual representation an agent has can affect how users perceive an agent, such as uncanniness in terms of size, and perception of humanness, as we just saw. So what's next? In terms of future work, we're looking at exploring different sorts of tasks, like real-world scenarios for AR, to see how that could influence user perceptions. You can think of using an AR headset with an agent in everyday life, or in industry, or maybe like while driving. And we're also looking at how we can really take advantage of this gaze behavior and the embodied agents to enable nonverbal communication in AR with agents, possibly through behaviors such as mirroring. Ultimately, all these things will help us reach our goal of understanding how to create better virtual agents for augmented reality. And with that, I'd like to give special thanks to my co-authors, Jesse Smith and Jaime Ruiz, and thank all of you for listening.
Thank you, Isaac. Any questions in the audience?
Yeah, hi. I guess I have two questions. The first is more of a comment. Like, between your scenarios, you varied at least two things. You varied the embodiment and the voice. So I have a problem with accepting conclusions drawn to the embodiment if you also change the voice. So maybe you can comment on this. And the other thing, which is more of a question, is I think it would be fun to have like a little guy on the desk or like a little figure on the desk. But I wonder what happens if you use this agent in real-world tasks. Like, I think at some point you just want the thing to do what you want, and you don't really care if there's an embodied figure. So I wonder if you thought about this. Like, if someone long-term uses your like an agent like this, do they really care about the embodiment, or do they just want to get their stuff done?
Mm-hmm. Right. No, that's a really good question. I think for that, at least having, right, I did talk about this sort of novelty effect that emerged, right? And again, we'd need more research to see if that wears off, right, eventually. And you could definitely think about how tasks would potentially affect which agent they would prefer, right? Again, we looked at distraction as one possible factor, right? Having something like a little guy running around might be a little bit distracting for something critical like driving, for instance. So definitely that's an avenue that we're looking at in future work that would definitely be interesting to explore.
Hi, I'm Bjorn. I'm from Uber. I'm really happy to hear you sort of comment and speculate about some of these other tasks, in particular driving, for obvious reasons. I'm curious to hear about this more, because it seems like the aspects of the agent that would appeal most to the user would depend a lot on the agent's goals. The user's goals in that given scenario. So this is sort of like a game. So like this idea of like a small, amusing little helper, is kind of consistent. So I'm wondering if you could speculate a little bit more about like what kind of traits you think would be good or bad in like a driving context, or in something else like a typical Siri or Google Assistant task, like just information retrieval kind of thing.
Sorry, could you repeat that last part?
I'm just kind of interested to hear you speculate about like what specific traits you think might appeal or not appeal to users in like a driving task in an agent, but then also like in maybe a more generic like information retrieval task, just like how many pounds in a kilogram kind of thing.
I see. I think at least for driving tasks, we might expect them to favor, right, disembodied voice a little bit more, just based on, right, not wanting to have anything distract them from the road. But possibly for those kinds of scenarios, you could have, in terms of like traits, I would think possibly having the agent wear clothes or whatever, more casual clothing or something that would fit like the scene of driving, for instance. Maybe have them in a tiny little car or something like that. But really, there's so much in terms of the design space of just the visual appearance that, right, in our study we focus on sort of these different classes, big human, small human, smart device, and disembodied voice. But really, there's a lot more research that needs to go into this. And I mean, this is exciting because we're kind of just starting off with AR headsets, and so we'll move forward.
Hi, Ferris Wallace, Volkswagen. Just less a question, more a suggestion on this scale of embodiment. You went from toaster to human quite fast, so maybe something in between, something like an organic pet-like blob thing might be interesting to have the benefit of the relatability, but not the offside of the distraction or the lot of fixations with the human. So maybe something in between would be interesting.
Yeah, no, definitely. I know in prior work they've kind of looked at sort of even gaze analogs, so like a box with a nose could be an analog for a head, for example, and they've found promising results with that. So something between maybe like a humanoid-looking robot may be interesting to explore, right? Something between that could definitely evoke different sorts of feelings, and we need to see what that's like.
Let's give another round of applause for Isaac. Thank you.
Thank you.